Hey, welcome back. This is episode 20 of the Salesforce Architect Playbook. Today, Double-DML is Are You Inning Your Orgs? Police Car Light Master Salesforce Idempotency Architecture. Architecting Zero Duplicate, Transaction-Safe Salesforce Integrations. Let's get into it. Here's what we're covering today. The silent Double-DML disaster then, defining the idempotency pattern then, schema design for idempotency storage then, resolving concurrency, and race conditions then, trade-offs, cache versus database storage then, architectural anti-patterns to avoid then, designing the idempotent apex rest pattern then, the enterprise integration blueprint. Stay for the last one, it's the piece most tutorials miss. Let me explain this simply. We've all seen integrations fail due to network hiccups, only to retry and create duplicate payments or shipping orders. Today, we are breaking down how elite CTAs design bulletproof, idempotent AP is on the Salesforce platform. Let's make sure your systems never process the same action twice.
I've struggled with this during high-volume spikes when our ERP retries calls. Standard upserts just don't cut it when complex business logic is running.
Imagine this, an external ERP system sends an order activation call to Salesforce. The integration layer experiences a network hiccup, times out at 90 seconds, and retries the call. In Salesforce, that first call actually finished and created the order, but because of the network glitch, the ERP never got the success message. When the second call arrives, Salesforce creates a duplicate order, leading to double billing and a massive headache for customer service. This is the classic at least once delivery problem that breaks enterprise trust. To fix this, architects design for idempotency, ensuring that calling an operation multiple times has the exact same effect as calling it once. We achieve this by introducing an idempotency key, which is a unique UUID generated by the source system for each logical action. Think of this key like a claim ticket at a dry cleaner. No matter how many times you present that exact same ticket, you can only collect that specific bundle of clothes once. The system recognizes the key, sees it was already processed, and simply returns the original result. Where do we store these keys? In Salesforce, we design a custom object called Idempotency Transaction with a globally unique index on the key field. We must track three vital states: processing, completed, or failed. Along with the state, we store the hash of the request body and the cached response payload itself. If a duplicate call comes in while the first is still running, we know to block it. If it comes in after completion, we instantly read the saved response and return it without running any heavy DML again. Now, what happens if two identical requests hit your Salesforce API endpoints at the exact same millisecond? This is where standard Apex code fails, and race conditions take over, resulting in dual records anyway. To prevent this, our Apex REST resource must query the existing idempotency transaction record using the forUpdate keyword. This locks the database row immediately, forcing the second transaction to pause, and wait until the first transaction either completes its DML or rolls back safely. It is the ultimate shield against concurrency bugs. As a CTA, you must weigh the architectural trade-offs of where you save this state. Platform cache is blindingly fast, boasting sub-millisecond lookups, but it lacks transactional durability and can be cleared during Salesforce maintenance windows. A custom object, on the other hand, guarantees transaction safety, and provides a permanent audit trail, but it costs you a DML operation and contributes to storage limits. For financial ledgers, always go with custom database objects. For high-volume, low-risk telemetry, platform cache is your best friend. Let's talk about anti-patterns I see in the field. First, never generate the idempotency key inside Salesforce. If the caller fails to connect, they can never send the same key again, defeating the purpose. Second, do not rely solely on standard database upsert on an external ID field. While it prevents duplicates, it will silently overwrite existing data with the second request's payload without alerting you that a duplicate event actually occurred, which can corrupt your operational data. The execution blueprint in Apex is beautiful when done right. Your REST class should first extract the header key, attempt to insert an idempotency record with a status of processing, and wrap this in a try-catch block. If the insert fails due to a duplicate key exception, you instantly query the record with for update to see if it is completed, returning the saved payload if it is. If the main logic succeeds, you save the output payload, update the status to completed, and commit everything safely. To scale this globally, your middleware, like MuleSoft, must play an active role. Middleware acts as the orchestrator, managing retries, caching responses at the edge, and ensuring the idempotency headers are injected consistently across all legacy backends. When you combine middleware-driven retry policies with Salesforce database-level locking, you build a zero data loss, resilient architecture capable of processing millions of payments without a single duplicate. This is how you design for enterprise-grade reliability at the highest CTA level. Alright, let's wrap up. Here are the key things to remember. Idempotency prevents duplicate DML and corrupt financial data caused by API retries. Using for update in Apex is critical to prevent multi-threaded concurrency race conditions. Store the serialized response payload directly inside the idempotency database record for instant replay. Keys must be client-generated, UUIDs, and passed via custom HTTP request headers. If this helped, hit like, it really helps the channel. Next up, Episode 21, Architecting High-Throughput Bulk API 2.0 Pipelines with Concurrent Control. See you tomorrow.